Hi, everybody. This is Slava Kurylak, and I am super excited for you to join me on this live stream as we talk about everything computer vision. Computer vision is one of the fastest growing areas of artificial intelligence today. And this live stream is meant to answer some of the most commonly asked questions that I get from the community, from my audience, about AI technologies as it relates to solving computer vision problems. And I decided to create this live stream to allow those individuals to ask me questions, to allow people to find out how they can leverage computer vision in their company. So this live stream is meant to be interactive. This live stream is meant to educate. This live stream is meant to inspire. And I would love to get started by first briefly mentioning who I am and what I do. So I have been in the AI space for the last 7 years. And as an AI expert, I have witnessed companies come and go. I have witnessed technologies come and go. But if one thing I've seen consistently remain is that computer vision technologies are being utilized today. Computer vision is one of the fastest growing areas of artificial intelligence, and there's a reason for that. And hopefully this live stream will share some insights for you and allow you to better understand, why computer vision is so important and why companies are pouring millions and often billions of dollars into computer vision. And what I do is I help companies to innovate faster. I do this by developing AI solutions that allow companies to crush their competition. And this is the background of where I'm coming from. So if you are a company and if you are interested to develop artificial intelligence software, then feel free to reach out. In the meanwhile, I will answer some of the questions that I find that are very important to address. Never now, amid 19, amid a world where technology landscapes are shifting, amid a world where businesses are struggling to innovate, businesses are struggling to respond in response to COVID-19. And in this new world, we see that certain technologies do better than others. And computer vision is one of these technologies. This is a very powerful technology that allows companies to really solve different types of problems. And I'm more than happy to dive further into the use cases. So what I'll do is I will simply pick what I think are the sort of most pressing questions that I find from the community. And I encourage everyone who joins this live stream to leave a chat, leave a comment, and I'm more than happy to address your question in real time. So let's get started. And the first question that I would like to address is, what is computer vision? Let me make sure that everyone will see this question on your screen. You should see it right about now. What is computer vision? This is a question by ZH on Quora. Computer vision is one of the areas of computer science that aims to replicate the function of the human eye, right? How do our eyes work, right? We often take our eyes for granted, but imagine we knew what it would take to replicate how our eyes work. This is the fundamental question of computer vision problems. Can we replicate how we as people perceive the world? And if the answer is yes, then what does that entail? What does that look like? So if our purpose of replicating how our eyes see the world is to create a digital equivalent, then computer vision is simply the software which today is powered by AI technologies And this software is allowing computers to understand the world by interpreting visual data, right? So software that interprets data. So this is the core functionality of computer vision. We are creating software that understands imagery, and as soon as we apply a temporal aspect, a time to the image, now we have video. So we're understanding images and video. Computer vision is simply the framework, if you were, if you think of it like a framework in our path to better understand the world by understanding what we see. Computer vision is simply a technology that is used to understand how we see things. Examples of computer vision, well, there are many, but you may have heard of some of these applications. The most common that you are now most likely using is something called facial recognition software. And these software are very, very common, especially among the population that uses the latest smartphones. So facial recognition is one of the core features, if you were, of the latest smartphones. The other very, very common example that we see in the modern world, computer vision shows up as autonomous vehicles. When you have a vehicle that can drive by itself, when it can navigate by itself, you now are using computer vision software. And autonomous vehicles today is one of the biggest ways that companies are using computer vision technologies, because in a way, people and companies are creating new industry by allowing machinery to operate by itself. This is a truly groundbreaking technology because it allows people to very, very problems when it comes to navigating vehicles, when it comes to driving cars. And those problems include everything from autonomous control, right? Autonomous steering. You have the robotic control of the vehicle itself. And then you have all of the visual aspects of computer vision models, which include understanding what the car sees through models like image classification, or perceiving where objects are, sort of as the car moves along. And this is a very common problem called object detection. And sort of the other very, very common use case of using computer vision for autonomous vehicles is something called semantic segmentation. And there we're really creating a mask, if you were, among every object that the computer detects. So now computer is able to differentiate between several objects that are that appear to be together, and each object now creates it has its own mask. And if you think of it like from a perspective of, if you have a pedestrian walkway and you have lots of people crossing that walkway, well, each person represents a single mask. And so object detection models are aiming to detect each object, each person, as they walk by the car. And semantic segmentation models are aiming to create a mask or create a contour around each person. So this contour is super important because now computers can understand where is that edge, right? Is that edge close to the car of the person, or is that person further away? So this is how we're using these technologies in the context of leveraging computer vision. So I gave you a few examples. I know I have focused on autonomous vehicles, but I'll share with you two other examples. So far we talked about facial recognition software. The second is autonomous vehicles. The third very common application of computer vision is something called emotion recognition. And here we will see more and more technology being adopted using this particular problem, where we're aiming to understand how people behave through their emotions, right? So what are you feeling? Do you feel happy? Do you feel sad? Do you feel anxious, frustrated? If a computer can detect the emotional state of the individual, now they can drive massive value to the company that uses that data, right? Perhaps we're looking at a customer service, a scenario where a system is able to recognize a angry or disgruntled customer or employee. All this information is now fed into a machine learning model, and that model is able to at first predict and then later detect what is that emotion, right? And detecting emotion is a key component in understanding people, which allows people to then better deal with others. So third example of computer vision is something called emotion recognition. And emotion recognition is one of the best ways that companies are using computer vision today, especially those who want to understand sort of human aspects of dealing with people. But the fourth example I wanted to share with you, and I'll cap it off with 4, which is gesture recognition. And gesture recognition software is, I believe, the next best way to better understand people, because now if I'm gesturing to you, then you can understand that my gesture means something, right? If I expand my hands, that's one gesture. If I contract them, we have a different type of context. So being able to understand gestures is the 4th example of computer vision, and hopefully that gives you more context. So again, we've talked about facial recognition software, we've talked about autonomous vehicles, the emotion recognition and gesture recognition. These are just 4 examples of AI systems that are being developed today by companies around the world. And the next question I see from the community is, what is the difference between image processing and computer vision? We have what appears to be 2 separate domains or industries. However, they are one and the same. Image processing is a step in the computer vision modeling process, right? So imagine we get some data as input. We need to then process that data, that visual data, and how we process it is usually using a variety of different techniques. And this step in the processing pipeline, if you were, is called image processing. Then we start to go down the path of image analysis and inside, for example, generation. So image processing is a step in the computer vision process. It is often a necessary step because we must make sense of the information that's encoded within the images or found within the images. But I do want to emphasize something here, that image processing and computer vision are usually, or let me just be more specific, more traditionally have been requiring developers to manually encode or define visual features and perform feature extraction. So for dozens of years, since the first sort of inception of computer science, since image processing and computer vision's models began to be formed, which was in the 1960s, you have the attempt to create a digital process of the physical world, right? So we're creating a digital analysis of an image. And for many years, right, since 1960s, sort of the inception of AI, to about 2012, we have sort of the manual method where some people are using machine learning, but predominantly they are handcrafting a set of features. They're being very explicit when they write algorithms in order to guide the system to look for very specific patterns or imagery patterns. And these manually handcrafted features, often referred to as feature engineering, is one of the most time-consuming aspects of machine learning-driven image processing and machine learning-driven computer vision. However, in 2012, that all changed. And I will later come back to this milestone. And the 2012 milestone is very important because in sort of from 1960s to 2012, primarily people were creating manual features when it came to classifying what is an image. From 2012 and onward, we now have a new approach. This is where we're using deep learning. And here, for the first time since 2012, deep learning practitioners did not have to manually say, here's what an ear of a cat looks like, here's what whiskers of a cat look like. For the first time, deep learning engineers were able to say, okay, system, okay, computer, figure out what is a shade, what is a tone, what is structure, what is brightness by yourself. And then I will tell you what is the the output of that model. So through supervised learning, through deep learning, the image processing and computer vision industries were fundamentally changed. And this change was driven by deep learning. And this change did not require practitioners to write thousands, if not millions of lines of code to specify what does an ear of a cat look like. And back to this model in one of the upcoming questions, but I do want to emphasize that being able to understand that computer vision, image processing, while they do not require the use of AI, and they were initially established without sort of the context of artificial intelligence, today they are primarily solved by deep learning. And this particular approach allows companies around the world to achieve state-of-the-art performance. So to recap, image processing is a step in the computer vision process. It does not require machine learning or deep learning. However, today, the biggest companies, the most successful companies are combining image processing with deep learning. They are combining image processing, deep learning, and computer vision together. So that hopefully answers your question. The follow-up question to that is, let me make sure I get that right. Right there. How does computer vision work? Anonymous on Quora asks. There are many ways that you can think about computer visions, but the best way, I think, is to realize that computer vision models are simply aiming to solve imagery and video problems. And there are actually hundreds, if not thousands already, models or problems rather that computer vision is needed for. Right? I'll share with you 5, and hopefully that gives you some context. So here are 5 methods, and again, I'll touch base on this question again. Here are 5 methods for how you would go about using different types of computer science methods to solve computer vision problems. And by understanding the method, often you can better understand the way that computer visions work. So the first way is to develop an image model. So computer vision models are also leveraging various methods of sort of storing imagery data into a model. That's called an image model. That's one. Second is generative models, where we're creating data, we're generating data, and we're storing that into a container or a model. Third way is convolutions, feature extractors, and fifth one is pooling operations. So these are just some of the ways that can be used to solve computer vision problems. You just pick and choose which method that has been previously established in computer science area is best suited to solve the problem, and hopefully that gives you context, and that hopefully answers your question. So the next question we have on the list is, how do I learn computer vision? And this is a question of education. Anonymous on Quora asked this question: the best way to learn computer vision is to solve problems, right? The best way to learn is to build. Computer vision today is learned by solving computer vision problems. What are computer vision problems? Well, today there are hundreds, if not thousands, of different types of problems you can solve. Again, I'll share with you 5 to keep things simple. Semantic segmentation is number 1. Image classification, object detection, domain adaptation, and image generation. So these are different types of problems that can be solved using computer vision. And it is by learning to build an image classifier, it is by learning to build an object detector, you can learn how computer visions work. Super critical. If you want to understand how technology works, you advise to understand it, you must. And I remind everyone who joins this live stream, this is an interactive live stream. If you are joining, say hi, leave a comment, and I am more than happy to address your question. And the next question that I see on the list is, Amy asks, what is the best school for studying computer vision? The best schools are led by the best researchers. And so without giving a specific name, I will give you a guideline, right? You want to find researchers who you admire. And there are many places you can do this. One example is GitHub. GitHub is a place where researchers and practitioners share openly their source code for their work. So if you find a source code, you often have core contributors. That's one way to do so. The second way is to look on Google Scholar, right? Oftentimes, the researchers are creating a preprint or a final print of their research paper, and it shows up on Google Scholar. It's one of the best places to go to for those who are unfamiliar. It's a great resource. So what I'll do is I'll share with you the third way that you would go about finding machine learning practitioners, specifically researchers. And the third way is arXiv. arXiv is one of the core sort of repositories, if you were, of research papers, preprints that are aiming to create a impact on the world. And this collection of preprints is very, very large. It's very, very diverse. So if you find a researcher who is on arXiv, on Google Scholar, on GitHub, then this is step 1, right? Find somebody you admire. The second thing you want to do is you want to follow in their footsteps. You want to do what they do. You want to learn from them. And the third thing you want to do is you want to move beyond them. You want to take their work. You want to stand on their shoulder. You want to leverage their domain expertise, their technical knowledge, and you want to now move forward. You want to create your own trail, right? If you're a trailblazer, you will now be seen as the next leading researcher. And the reason I mention researchers as opposed to schools is because if you are focusing on the researchers, you're also focusing on the human aspect of artificial intelligence, which is by far the most important when you are learning. When you're starting out, when you're in the inception stage of getting familiar with the technology, when you're in the early stage of growth, of just learning to tinker with technology, it's super important to find people who are motivated, find people who are knowledgeable, find people who are passionate. Those are three criteria you cannot compromise on: intelligence, passion, and integrity. So if you find the researcher online, ask them, hey, do you teach? If they teach publicly, what school do they teach at? If they teach privately, find out how much would it cost for you to learn from them, right? Maybe they can offer you one-on-one education. When you find that researcher, they will be more valuable than AI education because they will directly transfer their passion, their expertise to you. And that is far, far more valuable than just picking a school based on rank, just picking a school based on cost, or selecting a school because you do not want to listen to your when it comes to figuring out what school is best for AI technology. Instead, you want to find researchers, find people who are already doing what you want to do, and you want to follow them. You want to knock on their door. You want to ask them questions. You want to ask, do you teach? So this is the best possible method for learning computer vision. Find other computer vision researchers. Ask them if they teach. If they don't teach, don't be discouraged. You can always ask them a question by email, and this will give you the foundation you need to be able to learn computer vision. We now have another question, and it is from Sarah. Is computer vision all about deep learning now? Sarah and Cora asked this question. Deep learning is one of the domains of artificial intelligence. So I want to come back to a reference I made earlier in this live stream where I said, look, remember 2012? This is the milestone where deep learning models for the first time began to be applied in computer vision applications. Before 2012, people were manually defining, manually selecting and engineering features. After 2012 came a very important breakthrough. Deep learning computer vision models did not require practitioners to spend hundreds, if sometimes thousands of hours to do what is now able to do by computer automatically, right? So deep learning models were a big time saver. And in this approach, the computer vision industry exploded, right? We saw massive growth, massive investments, massive adoption. And this was all thanks to supervised learning. This was all thanks to deep learning and computer vision was the lucky recipient of that growth. So in a way, computer vision, the methods and algorithms were piggyback off or riding the bandwagon if you were using AI technology. And that is a super critical milestone. So what happened in 2012, right? Like, what was the breakthrough? And feel free to do research after this live stream, but I do want to bring up something on the screen, and hopefully that gives you a understanding of what was that tipping point, what happened in 2012 that created a shift in the industry. And to do this, I will share with you my screen, and on the screen you will see a research paper, and this research paper was sort of the impetus for the 2012 breakthrough. Let's do this. So the first thing you will see is my screen. Making sure that this is working. And you should see two screens side by side right about now, and I will make sure you can see that in more details. Okay, so I'll also send this link for those who are interested on the chat, and feel free to check it out. So AlexNet is the link that I have on my screen at the moment. AlexNet is one of the first models that was developed using a new approach called convolutional neural network, or CNN for short. And AlexNet was that sort of breakthrough paper that allowed what are considered deep CNNs to understand images by performing image classification. So what this means is that you could analyze, in this case, millions of images. And this analysis was done using this novel methodology or algorithm, if you were, called CNN. And ImageNet was the name of this approach. So after this research paper, you had like massive adoption of CNNs. You had massive adoption of computer vision models, because for the first time you could save yourself lots of time. For the first time, companies around the world, they did not need to hire data labelers. They did not need to hire massive teams full of data scientists and machine learning developers, because they could now use a model like AlexNet, or rather ImageNet. And ImageNet was one of the key ways that it was implemented. So I just want to make sure that I have the right model here. So the model I actually have in mind is AlexNet, not ImageNet. I know they're super similar. So this is the real model that I wanted to mention. Again, I'll share the link, so for those who are interested, they can see that. ImageNet is the model. ImageNet. Again, this is the model that was released, like I've mentioned, in 2012. This was the breakthrough that occurred. AlexNet breakthrough came later in 2017, I believe. But ImageNet, again, the goal was the same: to develop an image classifier, to use a CNN to save companies a lot of time. So the way the system worked is, it simply would create a model by training millions of images, and once those images were trained, then that model was packaged into, think of it like a container, right? And so ImageNet was simply that container. it allowed companies to come in, use the container, the model, and then simply modify it slightly for their use case. So how would this work, right? So like what does that mean? So I talk about this term of containers. The technical term for this is called pre-trained models, right? So today, computer vision is widely adopted because of pre-trained models. So how does that work? So when you have the circumstance where, let's say, we have a research team and they create a very large data set of images on cats, they simply label each image to, for example, a specific breed of cat. And the goal is to develop a cat classifier. So in this context, we have the circumstance where a company comes in, and let's say that this model is trained on cats, and let's say that for this purpose of this example is that the ImageNet is trained on cat pictures, right? Now you have a new company coming in, and let's say they're a healthcare company, and for the first time in 2012, companies would be able to leverage the pre-trained model. Let's say that's ImageNet trained on cat pictures, to train on their own healthcare data. So they leveraged one model to build the next. So this idea of pre-trained models became super popular. It transformed how computer vision models were sort of leveraged. It transformed how the imagery problems were solved. And it allowed companies to use previously trained models to save themselves lots of time. Hopefully that gives you an understanding of the complexity that deep learning entails. At its core, AI is simply solving problems. So just wanted to emphasize that if you have a problem, then AI technology is one way that we can solve that problem. And computer vision is just another way we can solve that problem. Kiat on Quora asks, what are the seminal papers on computer vision? Yes, there are actually many papers, right? Every day we have thousands of papers being released in the public ecosystem, right? The question then arises, what is seminal? Like, what is a groundbreaking, perhaps, research paper? Well, if you're talking about computer vision, then I highly recommend, Kiat, that you look back and you ask yourself, okay, so what models or architectures or methods were crucial in the development of computer vision models? And 3 papers come to mind. Okay, 2 are related to the models that saved everyone a lot of time in getting started, and the 3rd is related to a brief review or an overview of the technologies being used today. So on my screen, I will shortly pull up the research paper, and hopefully that gives you the understanding that you can go ahead and actually search this up yourself. Feel free to look this up, and definitely very, very valuable that you do. So if you wanted to better understand where these papers are being used, the best way to do so is to read them. And after you read these research papers, now you'll be able to better understand, what what happened that research paper become so important, and what did that research paper explain? And so I've so far pulled up 2 of the 3 links on my screen, and I'll share with you shortly the third that you're more than welcome to check out. I just want to make sure everything is working on my side here, and that'll give you a understanding that you can go ahead and learn more about this. Okay, so we have 3 models, 3 different, I would say, research papers for you to look at. So the first is, and you'll see that come up on your screen right about now, deep residual learning for image recognition. Now, this is a super important, very, very important research paper, because today this is the most popular, and I mean #1 model that's being used today. It's called ResNet, ResNet. ResNets are basically what has allowed computer vision models to become much more accurate, much more usable by companies around the world. ResNets became very important models, and this is a research paper that was actually released by Microsoft. You can see that here. So ResNets, what happened, right? So how do we know that it made an impact, and what was that impact? And let's do a super high-level overview. Like I mentioned, ResNets is the best possible, the most adopted CNN today. It describes this model in more details. It was released actually in 2015, so about 3 years after the previous ImageNet, and it has been cited, listen to this, more than 60,000 times, right? So what that means is that other researchers around the world have recognized that it's important, have recognized that it has impacted their thinking and their research. And so citations are simply a way to give credit from one researcher to the next. So when you have a research paper in the AI community, in the computer vision community, that gives you 60,000 citations, now we're talking about a very prominent, a very important research paper to analyze. So, if I zoom out, we can see that we basically have 12 pages, and feel free to skim this. Feel free to read it if you have more time. What I will do is I will share with you the link to this live stream, to this particular research paper, and then you're more than happy to actually dive deeper and see how it can be applied to better understand computer vision. So the second research paper, super critical, ImageNet. I've mentioned ImageNet briefly, but here I'll have a chance to just emphasize something here, that again, this innovation occurred in 2012. Since then, this particular CNN is the second most popular model that individuals and companies have used. It has been cited more than 70,000 times, right? Which makes sense because it came out first, or at least one of the core initial models that made pre-training possible using computer vision. And the next research paper that I think you'll find quite useful. The link for ImageNet that I previously shared in the live stream is Deep Learning for Computer Vision, a brief review. So this is a super, super cool research paper, and I will also share with you the link. So feel free to check that out. Awesome. All right, so what is this Deep Learning for Computer Vision review? Well, actually, it's one of the few review papers or overview papers that I found that allows you to grasp what's happening, and it's only 14 pages, right? So if you want to understand what is happening in computer vision today, you must read this. This will get you up to speed. This will allow you to see holistically where things stand. I do recognize that it's a technical paper and it does require some understanding. Having said that, you can read this more than once. You can skim read it. You can read the abstract, the intro. It's up to you. Pick and choose whatever method of reading works best for you. But this is a great overview, and I highly, highly encourage it for people who want to learn more about how you would go about using computer vision. So research papers are an amazing way to do that. Okay, coming back to our questions. And the next question is anonymous on Quora. Let me just make sure that it's working here. Perfect. Is computer vision unsuccessful? Anonymous asks, is it not successful? Well, let's think about this, Anonymous. The global computer vision market size is expected to reach close to $20 billion American by 2027, right? So in 7 years, it's expected to grow by approximately 7%. It will reach 20 billion, right? So is it not successful? Well, by the size of the market and more importantly, the fact that it's growing, it means that I would have to disagree. And computer vision actually is today by far the most adopted AI technology, the most adopted space for companies to dive into, because it makes sense, right? If you're dealing with imagery, if you're dealing with video, if you're dealing with visual data, computer vision is where companies are using their talent today. Computer vision models are solving imagery data, and we know that by how much money companies are spending on computer vision and research and development. I'll give you one number, and hopefully that cements the size that and the sort of the extent of different budgets that companies have today. So let's look at Amazon. Amazon is one of North America's leading e-commerce solutions. They are crushing the AI space because they're leveraging AI technology, not just in their products, but also in their services. They have a very diverse cloud services team called Amazon Web Services, or AWS. And their expertise has allowed them to dive very deeply into the AI rabbit hole. And in doing so, they realize the massive impact that AI and research has on their company. So Amazon is crushing revenue, especially as more and more individuals are forced to stay at home, as COVID-19 spreads, as second and tertiary waves are around the corner. Amazon is pouring, listen to this, billions of dollars into research. So here's a number for you. In 2019, that's just last year, Amazon invested close to 36 billion American dollars into their technology products. Now, it does not mean they invested 36 billion into computer vision or AI, but it does mean that a big chunk of it was leveraged to do computer vision research. So if the market is growing, if companies are pouring money into research, then to me, that's an indication that this is a successful area of computer science. This is a successful implementation that allows companies to gain massive revenue. And so to answer your question, I believe computer vision is very successful, if not one of the most successful implementations of AI technology today. Let's get going. I'm super excited here. The next question is, what are the best resources for learning computer vision for somebody with background in probability and linear algebra? I just want to make sure this shows up on the screen. Anonymous on Quora asks, what are the best resources for learning computer vision for somebody who has a background in what you describe as probability and linear algebra? If you know probability, you know the foundations of logic. If you know linear algebra, then you know mathematics. So the next step for you is to study statistics. And once you know statistics, then you'll be able to apply deep learning models, which means you can now achieve state-of-the-art performance in different types of computer vision problems. So to recap, study statistics. That'll set you up for a wide range of applications using deep learning, and that will give you the necessary skills to solve computer vision problems. But to emphasize, you are well on your way to becoming a master of computer vision if you touch up, if you study, if you get really good at statistics. Probabilities, statistics, mathematics, logic, these are all elements that will help you when you're doing deep learning modeling. The one other oftentimes unusual advice I give to practitioners is to study biology. So why biology? Like I've mentioned to you a very computer science heavy approach, right? If you're looking at math, you're looking at numbers. Why would you go over into a different department? Why would you knock on the neuroscience department? And why would you talk to biology guys? Well, the answer is super clear. Because if we're aiming to create more intelligent systems that can mimic how we perceive the world, then one of the ways to do that is to study how our minds work. How does the brain work? Well, the brain is a biological being. So if we can study the biological mind, we now have the foundation to build a smarter system. And I'll share with you one example. Hopefully that drives home the point. And feel free to explore statistics in the meanwhile. But I just want to let you know that, a lot of the breakthroughs for deep learning came when people started to simulate or replicate the human mind, right? Deep learning was based on the concept of neurons. And neurons was possible thanks to somebody's insight. Somebody said, well, why don't we just replicate how we store memories, how we store information in our brain? Well, the brain works through neurons and synapses. So if we're aiming to store data, perhaps we just need to figure out a way to go from one neuron to the next, and perhaps a synapses. We would do that in the human mind. What if we can achieve the same thing in the computer world? What if we create a architectural model where each neuron is represented as a tensor, and we're connecting neurons through forward and back propagation, and we're simply pushing bits back and forth, right? So we start with sort of the initial layers of a neural network or a deep learning model, and then we add another layer, and then we add another layer, and we keep doing so until we get to sort of the finished product, the end result of what we want. But this process of going one layer to the next is how our minds work. We have these neurons that are firing, and the electrical signal in our neurons simply travels through our mind, through our brain. So if we have a way to replicate that, then we're better off in simulating intelligence. And simulation of intelligence is intelligence. If you think and that you're talking to a being that has thought, then that being, as far as I know, as far as I guess, is thinking, right? If you are simulating intelligence, then while it's not intelligence, you are as close to intelligence as possible, right? You are creating the next best representation of intelligence. So simulation of intelligence becomes intelligence. Again, it's a equation of how close are you to the reality, right? Simulation aims to achieve reality. Okay, so best resources: study statistics and study biology. And if you study biology now, you can solve new problems that are inspired by the way that the human mind works. That is a question by Anonymous. Mishti on Quora asks, which is your favorite computer vision algorithm and why? Okay. I love talking about favorites because it always changes. But today, my favorite algorithm is called generative model. So this is my favorite methods, rather. My favorite model based on that is called generative adversarial model, or network, rather. These terms can be tricky. So generative model, think of it like it is a method that is often used in computer vision, right? Like we can create image models, now we can also create generative models. So generative models are not just storing data, they are generating data. So imagine you go to a computer and you say, hey, computer, generate something for me. That's a generative model. So generative models are an excellent way that we can break through a lot of paradigms. So, and the reason I mentioned this is my favorite method is because with generative models, we're coming up with something new. We're coming up with something novel. We're coming up with something that perhaps combines two things that we have taken for granted. And in coming up with something new, we can often spark an insight. We can often spark something that is valuable, right? So that spark allows us to then use AI in its best, use AI in its functionality. So generative models are my current favorite method of using computer vision. So my favorite model, to be more specific, is a generative adversarial network, or GAN for short. So GANs are one of the techniques that is a truly groundbreaking model, because it actually think about AI. Okay, so let's break this down. So traditionally, AI systems have been thought of as, or let me be more specific. Traditionally, deep learning models have been considered black boxes. You have data coming in, the model does some magic, and you have data coming out. The black box analogy represents the idea that when you have data coming in, well, you don't know how well that data is going to, you don't know the methods that the system uses behind the scenes well enough for you to know how it's coming up with the output or the prediction. And so it's called a black box. And generative adversarial networks was a model released by Goodfellow in 2014. And this model said that, well, what if there are not one models, but two? And what if they're working side by side? Think of it like two AIs. You have one model that does, for example, that is able to capture data. And then the second model is able to make a guess about the first model. So usually this is called a generative model and a discriminative model. And they're feeding off each other, right? One generates data, one says, is this data real? This is one way to think of it. Another way to think of it, like the analogy, the artist and the art critic. I created a new art piece. I think it could be done better. I created a new art piece. It looks really good. So the two are synergistically feeding off each other. And GANs are my favorite because they allow us to generate new insights based on data that did not exist before. And what they're primarily used for is image generation. This is where companies are leveraging imagery data, and they're creating images from scratch. Very, very powerful, very cool tech that allows people to click a button and get a new image, click a button and get a new video, right? It's truly transforming the way we understand or create things as well. So favorite method, generative model. Favorite model is generative adversarial network, or GAN.